discussing theoretical probability. And the example we're going to consider is of tossing to die. So in Python, I've written all the possible outcomes for tossing to die, and it's displayed right here. Okay, so when tossing to die, for example, the first die could land a 3, the second die could land a 1. Okay, uh, so here are all the possible outcomes. We can see that there are 36 possible outcomes. Um, this is predicted by what's called the general counting principle because the first outcome of the dice can occur in 6 ways. The second outcome of the dice can occur in 6 ways as well. When we multiply them together, we get the entire sample size of 36. And so the general counting principle, which is right here, says if event A occurs in n sub a ways and event B occurs in n sub b ways, they can both occur together in n sub a times n sub b ways. Okay. Um, what we're going to do next is count how many times 7 occurs when we toss 2 die. Um, and so, for example, you could count it by directly from the sample space. And what I mean by a 7 is that the sum of the two face values of the die sum to 7. So, for example, this is an outcome of a 7, 1, 6. There's also an outcome of a 7 of 2, 5. Okay, and so there's more than one way in which the two die can sum to 7. If you count all of them in this sample space, you're going to come up with 6 ways that the die can sum to 7. And we verify that with this code here. The number of outcomes with sum of 7 is 6. And the reason why that is useful for theoretical probability is because in theoretical probability, the probability of an event is the number of ways the event can occur divided by the total number of outcomes in the sample space. So if we use that in this instance, the probability that the sum of the face values is 7 is going to be 6 out of 36. The number of ways 7 occurs is 6 ways. The total number of outcomes is 36. Now, I could get this from the theoretical probability, this true probability of 1/6. Could also use Python to simulate rolling 2 dice. So if I simulate rolling 2 dice, this is the code for it. Okay. And I would use a slightly different formula. I'll use the observational probability, which is the number of times we observe a sum of a 7 divided by the total number of observations. Okay, so if I use this here, if I do 10 trials, in 10 trials a 7 occurred with probability of 0.3. Now, if I rerun this, I might get a slightly different result, especially with a slightly smaller sample size. Okay, but here it looks like I didn't. So 0.3 times what I get here. So we can see, 0.3, it seems a little bit like it's a high estimate. What if we do that, but now with 50 dice? Okay, well, I get a slightly different result. In 50 trials, 7 occurs with probability of 0.18. Okay, and if I were to run this again, I'll get a slightly different result, 0.28. So, quite a bit different results depending on just randomness, right? So if I run this again, I'll get a slightly different result, 0.12 times. I like that a little bit better. It's more consistent. But, you know, the observations depend on random chance, because they are observations. Each outcome is random. Okay, so I get slightly different probability estimates. If I use 100 dice, I'm going to get 0.18. I like that even better. Okay, so notice the estimates go from 0.3 to 0.12 to 0.18 to 0.17 to 0.169, and that's the theoretical probability. So what I'm observing here is as the number of observations increases from 10 to 50 to 100 to 1,000 to 10,000, I'm getting closer and closer to the theoretical probability. That's a very good sign, and what it says is the more observations, the better. Okay, um, and that is the result of something we'll talk about later in this course called the central limit theorem. Um, before I leave you, just a few takeaways. Okay, Obs uh, the formula for observational probability, even though this is for a specific outcome, in general, the probability of A is the number of times we observe outcome A divided by the total number of observations. So that's observational probability. Okay. Theoretical probability is the number of ways A occurs divided by the total number of outcomes in the sample space. So that's theoretical probability, and the two are different. A third takeaway is what's called the general counting principle, the number of ways in which two things can occur together. Okay, is given by that formula there. Okay, thank you very much.